Hello, everyone. This is Christine from Greenbook. Welcome, and thank you for attending this webinar brought to us today by Expedite. We have Tim Lawton and Naira Musalam, and they're going to be talking about key methods that you should be using to optimize your market segmentation. A couple quick housekeeping items. We are scheduled for 1 hour, so we won't keep you any longer than that. If you'd like to submit a question, just look to the top right of your screen. You'll see a little green text bubble icon. Just click on that, and it will open the box where you can type in and submit a question. If you want to change the size of your screen, look to the bottom right-hand corner. There is a little box with a double-sided arrow. You just click and drag it to the size that you like. And lastly, we are recording today, and we will send you a link to the recording by way of email in the next 2 to 3 business days. So with that said, I'm going to go ahead and turn it over to Tim.
Thank you very much, Christine. Tim here, along with Naira. We are the co-founders of Segmentation. Segmentation is an end-to-end consumer insights platform enabling faster and more efficient research from survey build all the way through automated analysis. And today, we're going to be focusing on a specific research topic, market segmentation. Show these slides or change it. A few things we're going to be covering today about how to reimagine your customer segments, or perhaps even better, cover new ones. With a fresh approach and understanding of how technology especially can expedite a lot of these learnings in time to market. We'll cover some common pitfalls with traditional customer segmentations and the data captured around that, and perhaps how to make that more accurate, looking beyond surveys to generate market segments using things like max diff and conjoint experiments. And then lastly, looking at getting questions and creative around behavioral and psychographic questions to uncover and using automation to uncover certain segments in different ways. A few reasons why all this is important, not the least of which is that consumers now, and especially in the last couple of years, even well before 2020, are and increasingly become more diverse than ever with the purchasing habits, preferences, interests, and so forth. And it's all grown in importance is how you look at and target market segments so your messaging can actually resonate with those audiences. And, you know, the last 5 to 10 years, the economy has changed and how consumers shop, how they're engaging with organizations and brands, where they're engaged. And with things like social media and a lot of the cottage industry that a lot of the biggest players have created is how consumers are identified and I think more importantly influenced in the messages they're exposed to and frequency and so on and so forth. But it's also because of a lot of those changes that we can actually get a lot more data, look at asking questions in a different way to be able to identify market segments based on a lot of those things that, you know, go beyond perhaps maybe the traditional, you know, geographic or demographic type of split and customer segments. So I'm going to hand it over to Naira to kick things off, talking about the first topic here.
Okay, Thank you, Tim, and thank you, everyone, for taking the time to join us. So for the next 30 or 45 minutes or so, I would like to share with you some statistical methods, some methodologies, techniques that can really optimize your segmentation and in how you go about it. Some of it you're going to be very familiar with, and I'm going to just remind of like key things to bear in mind that are going to make a lot of difference in terms of the accuracy of the segmentation you have. Some of them are going to be simple methods, and some of them will be more complex methods. But I really wanted to start with the first technique that I think is the simplest thing consumer insights and researchers can do, but unfortunately, many times it is not done because we want to jump into the data analysis. And that has to do with like looking beyond what you immediately see. And what do I mean by that? We know that the vast majority of people rely heavily on the mean. I ask a question of, on average, how many snacks a day you eat, and I get the answer, and the answer is the average is 7, and I start the segmentation from there. So I start the segmentation from there by actually saying, okay, like let me segment it either above the mean, and I determine the range above the mean, or let me segment it around the mean, and let me segment it below the mean. And so it could be one of those approaches, and those approaches are very familiar. But what the truth is, and I always say, mean statistics can actually be pretty mean for the accuracy of your segmentation. If you don't take, let's say, the first 30 minutes to just do some exploratory around your data and go beyond just looking at the averages and deciding how to segment from there. One of the things we continuously encourage people to do is to look at things like medians, which tell you something about the middle value in the sorted list of numbers, looking at the mode that tells you about the number that occurred most frequently, and the standard deviation, which is like the variation that you see within a set of values. Now, you ask, why this is important? Because it tells you something about the way your data set is behaving, that the mean doesn't tell you the full picture of it if you only look at the mean. You're able to identify things like outliers. So let me just share with you a graph that I think just illustrates the point. If you were to take a look at the left, and if we were to stick with the example of how many times a day do you have snacks, especially in COVID times, and many people working from home. And
So much.
Yeah, right? And so if you're looking at just the mean, if you didn't take the time to take a look at the median and the variance, you go, oh, okay, it looks like there is about 7 meals an average. But if you do one of the two things of looking at the range of statistics, and that includes the variance, standard deviation, mode, or you even visualize, then you will be able to spot pretty quickly that there is something going on in your data set that you should explore a bit deeper before you go about your segmentation method. And so in this example, on the left, you see once I visualize and once I have the other statistics, if I look at variance and standard deviation, you're able to notice that this is a pretty large. When you have variance and standard deviation that are pretty large, it typically indicates one of two things. One, it's either you have some outliers in the data set that is really throwing off the vast majority of how the data is behaving, or you know that people are answering in extreme ways. So let's say I have 60% answering as 1, and I have 40% answering, the remaining answering as 10, but there is no average really. And that is very important, and that is incredibly important for segmentation, because it does determine the ranges you go about when you're creating the various segments you're trying to do for your own product or the client that you're serving. And so it is always highly recommended that you start with this one of look at your descriptive data and visualize your data, because if there is something suspicious going on, you'll be able to spot it pretty quickly, and it has massive ramifications. If you were to go and ask researchers and consumer insights people to what extent you do these type of stats before you start looking at like the segmentation. Sadly, we know from like meta-analysis that many people don't do that. Yeah, it's such simple technique. You can do it in Excel. You can do it in platforms that like automatically give you those values, or you can run it in any really analysis tool that you have. And so that is the first thing, the first one that I wanted to talk about. The second methodology or technique that I would like to discuss here is something that a lot in the industry use quite a bit. And that is the technique of relying on significance testing for segmentation. On one hand, it can be very powerful technique. You decide that you want to segment based on whether there is significant difference in likelihood to purchase your product, whatever your product might be. And there is power to that. And so you can take the two segments and say, okay, show me what is significantly different between two groups around likelihood of purchase, and then go about it this way. The few things that you need to bear in mind is that significant testing can actually also be a bit deceptive if you're not taking it within a larger context. And what do I mean by that? So sample size is something that gets asked about often. So when someone is running segmentation studies, what should my total N be? Should I go with 100? Should I go with 1,000? Should I go with 10,000? And the answer is, well, it depends on the audience you want to engage, but more importantly, rather than the sample size, you also want to make sure that you have representation, because you could have a sample size of 50,000, but if it doesn't address the various segments and quotas that you're trying to engage with, sample size is not going to really be that helpful. So always think about sample size in addition to the representation of the various segments you would like to have, and that can be easily controlled for when you have things like quotas, and so make sure you have your quotas set up correctly, because it makes a lot of difference. Another thing I wanted to share with this community is actually something what we call in us statisticians a little bit of like the dirty secret of statistics. Here is the reality. The larger your N is, the more likely you're actually going to find significant differences. So I remember in my school years when we used to go collect data for our thesis, and we have 1,000 respondents, and we're not getting our hypothesis confirmed because we knew the rules of statistics. One of the recommendation would have been, well, go and enlarge your sample size. So if you go from 1,000 to 1,500 to 2,000, the likelihood of you finding the significant differences you want increases, and that is something that gets debated quite often, of like whether this is actually a good indicator in terms of like in terms of segmenting data. You might be asking, well, why does that happen? And the reason it happens is pure probability. The more sample you have, the likelihood of variance existing increases. That is like one of the, if you will, of the rules we know about statistics. And so just be mindful of that significant, and don't be discouraged if you collect 1,000 responses and you find that there is no significant differences until you go, oh, how do I segment? Look deeper into the data and how you can look at it in meaningful way. One thing related to significant testing is actually something called like the confidence interval. So what you might be familiar with is like when you do significant testing, whether it's on a t-test or you do it on ANOVA or you do it on chi-square, you set up the alpha. And alpha is basically the error that you're willing to accept in terms of you reaching an accurate conclusion. In the field of both social sciences, life sciences, it has been agreed upon that like there are three values that get used often for either like publications, for conferences, that are hard to debate. And those are an alpha of like 1 of 1,000, then 1%, and then the 5%. Sometimes you see researchers, and especially like who are working on platforms and like Cytix or like others, where they want to adjust for the confidence intervals to like 90% and 80%, while theoretically it's something that you can do. What ends up happening is that it introduces massive amount of error to the data. And once again, from a meta-analysis, like in terms of like what we have learned in terms of what works and doesn't work, it's highly recommended that you actually stick with the values that have been agreed upon in the scientific community, and that is the 1,000, 1% and 5%. And beyond that is look for like meaningful variables, especially if you end up finding that nothing is significantly different or everything looks that it is significantly different. Significant differences is like one of the best and worst things that ever happened in statistics. And the reason being is, on one hand, it is a useful indicator. If the meaning of it is clear, and that is the probability that your answers and the values that you're seeing and the differences between them are beyond chance. This is all what it really indicates to. It doesn't tell you much about how meaningful that difference is. It just tells you, is this beyond chance or within chance? And this is why we highly recommend, like, not to get discouraged if you can't have any significant differences in your segmentation, or if everything is significantly different and you don't know how to go about the segment. So look for the variables that would make impact on the outcome you're trying to reach, either internally for your team or for the client that you're serving. And to just give you an illustration of what we mean by that, I'm going to hand it off to Tim to just like show you a video here that just illustrates the point.
Yep. And this is in Cytix we're looking at now, probably one of the oft-used features, creating pivot table. And just to highlight what Nara was talking about here, just quick straightforward tables. I think it's a 2x1 or 2x2. Viewing the data, there's a lot of different ways people like to dig into results, top down, bottom up, question by question, or an aggregate. But turning on significance test, obviously highlighting some, and then changing that interval to anything other, especially below. You can see how the table obviously immediately highlights like a Christmas tree. So a little bit tougher to decipher or dig into those results when everything is significant and everything seems important. But to Nara's point, or if you like me, I just listen to what Nara says and go from there, as usually the best practice and best way forward. But to be able to do that, to again, to see at the kind of the highest level what's significant, but just because it's significant doesn't mean it's important to your business. So it's those meaningful variables that, even if there isn't significance, it still could be important to the project goals or the actual insights, and especially in this case, the segments that are coming out. So it's one tool and one lens to look at it, but certain things to keep in mind as you're going forward.
And so to get to the third methodology that we would like to encourage the audience to use and think about when you're even designing your segmentation study, is to be by design preemptive. And what do I mean by that? When looking at some of our users and beyond that, when they're trying to do some segmentation studies, and it's not working for them, or like they're disappointed with the results, and they ask, hey, can we pick up your brain for 15 minutes on what to do with our data? One of the main challenges is when your data has low variance. And what do I mean by that? You ask, let's say you wanted to test 10 propositions or like 10 attributes about a product that you're trying to roll out, and then you want to ask about the packaging, the color, the cost, its benefits, you name it. And you're asking it on 1 to 10 scale, and the vast majority of people are answering, I would give it an 8. And you're ending up with 10 statements, and most of them are with low variance. You have 8.2, you have 8.5, you have 7.9, and typically, and rightly so, researchers get really worried. We just spend a lot of time designing it. You invested in the panels, and you're supposed to deliver internally, and you're looking at the data, and you go, how do I go about analyzing all of this? So to go back to what I said just early on, have a preemptive design. If you suspect that the type of questions you're asking are going to lean themselves towards what we call social desirability, that people are going to just on average answer a certain way, then consider going beyond simple surveys and venture into experiments. And why experiments are a little bit different? Two reasons, really. They have less social desirability, and respondents have a really hard time tracking actually the way they're answering. So I'll give you an example, and we don't have a time to go through like all of the experiments because there are so many of them, but some of the ones you see on the slides you might be familiar with, such as like max-diff experiments, conjoint, or concept testing, or just going beyond scale questions. And so let's just talk about max-diff as an illustration of the scenario. One way you could go about asking those 10 questions, saying on a scale of 1 through 10, how likely you are to what extent do you think pricing matters, the color, you name it. And that is the scenario where you end up with the average being 7.5 to 8, and there is no differentiation. Max diff, and for those who are not familiar with max diff questions and max diff experiments, they're all about understanding the level of importance consumers place on specific attributes you have of a product or a service, and those are familiar to many as like best worst scaling. You can ask it as just one question, but it's often the case that researchers and insights leaders have more than 10 attributes they want to test. What you could do is experiments. And in the experiments, like run things like max-diff experimental design, where it would meet like the golden balanced design, meet the golden standards of being orthogonal with equal frequency and things like that, where each respondent like gets exposed to 10 of them. And those type of experiments, like when you go to the output, you will have very clear what we call winners and losers in terms of attributes. It is very difficult to mess up max-diff designs and not know which attributes are actually like most important for your business. Same thing applies for conjoint. Same things apply for concept tests where you randomize exposure of different type of, like, let's say videos, images, you name it, to random respondents, and then you see how they perform with some manipulations. Now, after you do that, then it becomes very interesting to do segmentation based on these methodologies, just because you end up with way more variance and accuracy. I think one thing we have noticed is that, and like many users stick to asking multiple choice questions or rating questions, and those are fine. And I think historically what happened is that running all of these like max-diff, conjoint were costly to run, and you save them for specific projects where you wanted to do attribution testing. But in today's world, and like the technologies like available to this industry, you can actually use those methodologies for your segmentation, which increase the likelihood that you end up with differentiated segments and understanding based of them. And just to give you an example of like how easy that has become in the industry, I'm just gonna hand it off to Tim to show you a video here.
Susan already mentioned the two different types here. There's basic single question or experiment, where you're going to run them through, different numbers of sets, so obviously based on how many attributes you're testing in the proper set size. But as long as you know the attributes about the product or service you want to test, that's all you need to know to get started. And it's as easy as adding them in like you would any other question. Obviously, images and things like that you can test as well, depending on what you're trying to do, setting up your kind of best and worst, or least and most scales. And then in this case right here, the output we're looking at is from the experiment, so running through multiple questions, looking at, you have all of your stats and your coefficients, but a few different outputs there with the appeal, total, and utility. So looking at results based off of what was selected and seeing those rankings, what was also shown, so we're taking into a different denominator there with the total count, and then of course utility ranking to see how they directly compare to each other. So it's obviously the aggregate, but then if you wanted to start digging into those, you filter, compare, contrast to try to get at, again, the different market segments to see if preferences do change. And then, maybe best case, you're sort of in line with what you wanted to do from the product itself, the marketing, the messaging, and so forth. Or perhaps, looking at different, comparing, using some of those demographic variables, or using really anything else that you've captured in the data set to be able to dig into that data at different kind of granular levels, but all with, ideally, a click of a button, and seeing how things change and shape out to allow you to, decide what you want to highlight, build, R&D, market, message, et cetera, and so forth. Obviously, depending on the project itself, but a lot of utility there, especially to add on to kind of a typical kind of straightforward questionnaire.
Yeah, so thanks, Tim. The fourth methodology or technique to consider when you're doing segmentation is really going what we call like beyond your personal assumptions or even the business assumptions for exploratory work. Like when it comes to segmentation, really, we know of four types that consumer insights analysts do. One is based on demographics and some of the variables you see here you're very familiar with, whether it's gender, sexual orientation, religion, race, ethnicity, age group. Another one is geographically based. Where do you live, the country, the type of place, urban, rural, suburban. The third way to segment your data is really behavioral, and that is based on more of transactional data. And the fourth way to segment your data is more psychographic, where it's based on things like personality traits, values, motivation, attitudes, or interests. Now, all of these are important, and all of them are useful, and all of them have the business case actually to make. One thing we wanted to just highlight for the industry, and this is perhaps looking into more of like the future and what a lot of us will need to deal with, is that the collection of things like passive data is going to become increasingly uphill battle for many, and that is just simply by the fact that Google and Apple and all of the tech giants are going to be tightening up the privacy policies they have in terms of collecting passive data on people without their consent, and what the default will become. So giving the context of that, I wanted to highlight a technique that doesn't get used as often, and I think it doesn't get used as often because quite frankly, historically, it took things like expertise, deep expertise, or it took a lot of effort, or it costs you a lot of money to be able to run that type of study, and that has to do with exploratory cluster analysis. And so you might be familiar with things like optimized k-mean clustering, or even hierarchical k-mean clustering. And today, if you were to look them up, actually, just to Google them, you will see that they fall under what is called unsupervised learning, which is branch of machine learning. And these are very fancy words that can quite frankly sound a bit scary, and you go like, I don't know how to do hierarchical k-mean clustering. I don't know what is optimized hierarchical k-mean clustering. But many researchers have been doing it for many years without even labeling it as unsupervised learning or even machine learning. But nowadays, in the age of everybody wanting to talk about machine learning and wanting to be also part of it, I think it's just an important thing to clarify and talk about it. And all what you're really doing is that you're picking a random spot in your data set, and then the data starts performing learning around the other data that is close to it in proximity, and doing it in iterations up to a point where you end up with let's say you can tell the software, I would like to see the 3 clusters like that are most differentiated, or you can tell the software, I want to see the 6 clusters that are most differentiated. Now, what's interesting about this methodology is that it really goes into segmentation with zero assumptions and with zero consideration into what type of variables should be clustered together. There is an advantage to it and disadvantage to it. And I'm going to start with the disadvantage, actually. The disadvantage is that sometimes you may end up with variables being clusters and personas that don't make any business sense to you. And from there, you can start isolating some variables, getting rid of some, and then rerunning the simulation again to see what type of segments emerge again. And quite frankly, there is an element of what I call like the loss of psychological control, that you no longer control like the type of clusters. The algorithm is going to tell you, well, this is an important cluster you need to be looking at, and it's quite differentiated from cluster B. The advantage of that is that you actually may end up coming up with segments and personas that are relevant to you and that are insightful, that you haven't thought of, because we human beings are bound by our assumptions, and that is just who we are as humans. And that's where computing and things like unsupervised learning can actually complement what we do as humans and think like the right thing to do. What we encourage always our users to do, and even when we talk about it, is to say like, look, all what it's gonna cost you is a click of a button and maybe 30 minutes to be to look at it, to look at like the clusters and think about it, because it's no longer gonna cost you the the budget, or even you need to hire expertise. And what it could really do is then just complement the other type of segmentations you're doing that we're talked about, and that is more based on whether like the variables that are meaningful for you, or like relying on the experiments, or doing any type of methodology of like the significant testing that we've talked about, while taking it in context and so forth. So that is the fourth thing I think we would like to just encourage this community to experiment with and think about. And Tim, maybe we can show a little bit of what we mean here.
Sure. More just getting at kind of the post demographic variables, how to, everything that Naira was just talking about, how to use different tools to get past that. And this, what we'll look at here, I am of the camp of not knowing how to do hierarchical k-means clustering myself, but I like to push buttons and can look at pretty graphs. So from here, all we're doing is telling the platform how many personas we want to create. And then from the drop-down menu, there is only a limited number of questions, and that's because this type of analysis needs a certain type of variable, in this case, a continuous variable, so like a rating scale questions. And that's where some of those psychographic type questions come in. How do you, scale 1 to 10, for example, in this case, looking at how important is price to your purchase decision, or how important is the brand, or, anything could be any level of interest or preference, however you want to design the questions themselves. But as long as you have that type of question and more important, the data structure behind it, you can instruct a platform to do the work for you, and you're just going to tell it how many personas you want to look at and across what variables. And in this case, we saw, a few of those come up. And then again, getting to the segmentation piece, that in and of itself, creating a couple of clusters in aggregate could be, that's where you end up, and you see those three clusters. And in this case, the one graph we're looking at here, I believe that's, price for one of those clusters is much higher than the others. And the others look, somewhat similar, but you could theoretically look, let's say we're talking about one product or one service or type of a company here, message different things for the same product to different people based off of their preferences. So it does allow you that level of granularity that, could be important depending on what the goal of the project is. And again, layering on filters and things like that on top of it, if you want to dig in even deeper to that. And they, again, a lot of these tools and methodologies, can be used across any type of project. Oftentimes we hear people say, "Oh, I want to run a segmentation study, and we need to, look at our segments, and it's just a singular thing that happens once in a while." But get back to one of my points earlier on is that, and I speak to this from personal experience, my own behaviors have changed drastically in the last couple of years, not to mention the last 12 months, how, where, when, and why I engage online and store with different companies and brands. So I think that the segmentation should always be top of mind, and it should be a continuous thing. So regardless of the type of project or questionnaire or what have you, you can and should be kind of digging into different segments all the time, and highlighting trends and things like that come up. And, this right here is one really powerful way to do that. It can often get beyond, again, kind of what you may have kind of typically looked at or thought to do, or in a lot of cases, Nara mentioned, having the time or expertise to do. But if you're like me, again, just click a couple buttons.
Great. And Tim, even before we talk about the last point, I see there are a few questions that we have, and perhaps we can make it just a bit more interactive. So I would like to take just a few minutes because they speak about the segmentation and what we just talked about. And so one of the questions here I have is, are you using significant testing to determine which variables to put into the segmentation analysis, or are you using the significant testing after you have run the segmentation analysis to highlight differences between segments? I think this is a great question, and the answer is why not do both? You can use it in the first stage to actually just do more significant testing for exploratory, because we typically think of significant testing as the final outcome, like where we do the segmentation and then the punchline is, and they are significantly different, which is completely valid and it's powerful thing to do. But there is also opportunity, I think, to do it early on before you do the segmentation, because if you early on ran all of the significant testing that you would like to run, I think it can give you what I call indicators that there might be something interesting going on here in the differences beyond statistical chance. And so my recommendation actually to do it at the beginning to determine how to go about the segmentation, and then you can do it at the end as well. And quite frankly, if you do it at the beginning and you identify the ones that are likely to end up with different segments or significantly different segments, then the final product or like the final segmentation is actually more likely to be significantly different when you look at like the three segments. The one thing I would just like to caution with is like when you have the three segments, make sure that the variables are not overlapping. If they are overlapping, then you have to correct for that and basically account for the fact that you have some data points that have the same basically being counted twice. The second question I have here about segmentation before jumping into the last point is, how do you determine which of the three is more appropriate? And so I'm assuming of the three is like the three segments that Tim just showed. So when you tell the platform, give me three segments. And by the way, you can do 3, 4, 5, 6, 7. Now, we always recommend that you don't go beyond 5. And the reason being is that there is a lot of meta-analysis in the statistical literature showing that a lot of noise get introduced after you go beyond the 5 segments, and you start losing statistical power. And so our recommendation is always to stay with 4 to 5 because they're like the most powerful. If you follow the technique, let's say of optimized hierarchical k-mean clustering, the 3 segments are the ones that are statistically most differentiated. Then what you could do is look into each one and see to what extent it makes sense to your business case. And that's something a machine cannot do. That's when you need the human expertise, the human talent, who know the context to be able to say, okay, this is relevant for my business, and maybe cluster B is not that relevant. The third, just one last question. We're being asked about which platform is being used. It's actually our platform, so it's Cydex. And so everything you're seeing here is on our platform. But to just in full transparency, you could probably see there are other software as well who do it. That everything that you see here is from our platform, Cydex. So to go to the last but not least, encourage technique for segmentation, and that one has to do really with rivalry we've seen in our industry for the longest time, and that is what is most useful, what is most powerful, is it quantitative or qualitative? Now, depending on your specialty, people tend to be biased. I happen to believe that they're both equally important and they complement each other in a very nice way. So typically when users do, or like researchers do segmentation, they actually shy away from text because you go, well, how do I go about that? In today's world and like technology, there's actually some nice solutions that are available. And so, technology has provided, I think, like opportunity for collaboration and expansion of how we look at data, but it's rarely used, in segmentation. We always encourage like the industry, like when we talk or like give some of these webinars, like don't be scared of text when it comes to segmentation. Sentiment is something you're very familiar with, so there's a lot of technologies that are able to do sentiment analysis. We do it on Cydex, and there are others who do it. And so you're able to segment your data on things like sentiments and using, complex models like SVM modeling or Vader modeling for sentiment analysis, and look at the data that way, because despite all of these super complex techniques that we have in our toolbox to do different types of segmentations, sometimes there is power in the simple things you do, and that is, at the end of the day, do people view my product or services as in a positive way, in a negative way, or they're in a neutral, I don't care, I don't know what to think of your product or service. And the nice thing about it, even if you collect like 2,000 responses, 5,000 responses, technology can actually help you do that type of segments in really seconds or minutes. But don't believe me for what I'm saying. Tim will show you a little example or illustration of what I mean.
It doesn't look like, oh, there we go. Looks like it's playing. So just quickly categorizing things here with frequencies and kind of being able to toggle through adjectives, nouns, verbs, and that type of thing. Searching through text, obviously, for certain topics that come up, or things that you want to either kind of seeing highlighted and floated to the top, or you want to dig into and look for, and obviously the sentiment there, in aggregate or per statement as well, and then being able to break out text responses and across segments and things like that to see how they may shape out. In this case, a pretty simple, straightforward example: males and females, but it could be kind of any of those categorical descriptive variables you have in the platform itself. And then again, you want to dig deeper, adding filters on top of that and that type of thing as well. But it's another tool in the toolbox. It's one of those things where limited open-ended text questions is probably the best for the respondent experience, but occasionally if you need to elicit some of that more concrete or detailed feedback, it's a good tool to have to be able to get a little more juice and value out of a particular project itself. And that wraps up all of the slides and the topics that we wanted to hit on. We sort of answered a little bit of the questions that came in the last few minutes, but in the few minutes we have left, I want to see if there's any other questions.
Yeah, there is a question about what was used to create the 3 segments displayed. Are they cluster analysis or latent class? In this example you saw, it is hierarchical K-mean clustering in this specific example, but obviously there are other techniques out there that are available. For the industry of consumer insights, we have noticed that this is like a technique that is familiar, that has been used, has been proven, has some track record. All what we did in our technology is just automated and make it accessible to use on any of your projects, whether it's a 5-question survey or 20-question survey. And the study doesn't actually have to be segmentation. It could be any type of study, but then you can use that and do very quick segmentation if that could maybe be cherry on top of something that you're presenting or something like that. And so maybe to just recap the topic and again, we thank you for your time, and we hope this has been useful. Our guess is that some of these material and content is familiar, and maybe some of it is new, and maybe some of it is familiar, but you never thought to utilize it for segmentation. And so we wanted to drive home really like 5 things, and that is, 1, look beyond what you see. So take 30 minutes to explore data, learn about standard deviations, learn about outliers. Number 2, significant testing is great, but it can be deceptive. Don't be discouraged or encouraged by it if you're getting everything that is significant or nothing is significant. Dig deeper into what else can you do. Really encouraging everyone to go beyond in their surveys, beyond just the surveys, and introduce an element of experiments, because you become just preemptive by design, by having diversity of questions, especially if you're worried that your results are going to be hovering around means, or you're not going to see variance because of social desirability. Go beyond your assumptions of segmentation and at least explore what statistical models and unsupervised learning would suggest to you. Maybe they'll be helpful, maybe not, but there is no harm. They can only add to the depth of your insight. And let's not be scared of combining quant and qual, and because there is power in combining both. And so once again, thank you very much for taking the time, and please feel free to reach out to us, to Tim and I on our website. All what you need to do is just mention your name and say that that you're on our webinar.
Thank you so much. And if there's any other questions that weren't answered, again, feel free to follow up either through our website, some high-level company contact info there, or feel free to reach out to Naira and I directly. We kept it simple. It's just tim@sidex.io and Naira@sidex.io as well. Thank you, everyone, so much again, and hope to see you soon in person at an industry event if we're all lucky.
Yes, that would be great.
Thanks again, Christine, and everybody.
And thank you. We appreciate you doing this for us today. And to all of you out there, again, thank you for being part of our webinar. We appreciate your time and your attention today, and we wish you well wherever you are.